Hello students, I welcome you all in the fourth video of laws of motion students. Today we will continue with uniform circular motion students and later we will learn laws of motion students. Here in last previous video we have already studied graphical derivation of equations of motion. Students, please remember there is difference between equations of motion and laws of motion. Students, I'll continue with laws of motion, but before I'll start with laws of motion, we are having a small concept, and that concept is uniform circular motion. So let us continue with uniform circular motion. Students, you can see in this slide we are having different figures like triangle, square, pentagon, circle. So here what I'm saying, suppose these are the paths. Students, suppose these are the paths. Suppose there is a vehicle which is following this path. When it will follow the first triangular path, the vehicle will have to take turn three times. Students, will have to take turn three times to complete the one rotation. Students, to complete one rotation. In the same way, when you will see square, if the path is of the shape of square, the vehicle will have to take turn four times. Students, that means direction will be changed four times. In the same way, when pentagon is there, we'll have to change the direction five times. The direction will be changed five times. But when we are talking about circle, that means circle, when we are talking, the direction is continuously changing. When we are talking about circle, the direction is continuously changing on each and every point. Students, on each and every point. So here, if path is circular path, that means direction is continuously changing. Students, we have already studied speed and velocity. Speed means only magnitude. It may be 10 kilometer, 15 kilometer per hour, it may be 20 kilometer, whatever speed is there. Speed, only magnitude is there. When we are talking about speed, there is only magnitude. But when we are talking about velocity, to represent velocity we need magnitude and direction both. Here direction is changing. Here direction is changing when we are following circular path. When we are following circular path, direction is continuously changing. That means we can say the velocity is changing. That means the acceleration is there. Acceleration is there, though speed is constant. Suppose the vehicle is moving with a constant speed of 10 kilometer per hour, but direction is changing. That means velocity is changing. Students, if a vehicle is following a circular path and the speed is constant, we can say it is a uniform circular motion. But at the same time it is also a accelerated motion. Why? Because direction is continuously changing. So if it is asked why the circular motion is an accelerated motion, you will say, though if uniform circular in uniform circular motion, the speed is constant, direction is continuously changing, and as the direction changes we can say that the velocity is changing. Why? Because velocity is dependent on magnitude and direction both. Velocity is a vector quantity, and that is the reason the motion, the circular motion, is a accelerated motion. Students, let us go through this. Students, here when we'll see, it is written, when an object is moving with the constant speed along a circular path, the change in velocity is only due to change in direction, hence it is accelerated motion. So you must have understood why it is accelerated motion. When an object moves with constant speed along a circular path, the motion is called as uniform circular motion. If speed is constant, we'll call it uniform circular motion, but as the direction is changing, we'll call it is a accelerated motion. Example, here one example is also given: the motion of the stone in a string or that of any point on the bicycle wheel when they are in uniform motion. Students, we are having a formula. If an object moving along a circular path of radius r, suppose radius is r. Students, suppose radius is r, any vehicle is moving along a circular path and radius is r. Students, radius is r, Then time taken is t to complete one revolution. Time taken for one revolution is t. See here, suppose there is a vehicle which is following the circular path having radius r, and time taken for one complete rotation is t, suppose is t. Then to complete one rotation, then the speed can be written as, students, distance upon time. Here distance means one complete rotation. One complete rotation of circle is nothing but circumference or perimeter of the circle, students. So here we have written circumference upon time taken for one rotation, students. Time taken for one rotation. So here we'll get speed is equal to circumference upon time. Speed is equal to circumference upon time, students. So here we are having speed is equal to circumference upon time. Now speed is given by velocity. So speed is there. Speed, if I am talking about only magnitude, it can be given by v, velocity. Circumference formula we know, students. Circumference of circle is 2 pi r, and time taken is already we know, it is t. So here velocity will be given by 2 pi r upon t, students. This is a small information about uniform circular motion, students. Let us continue. Now we'll continue with the next topic, and that is Newton's laws of motion. Here we'll start with the Newton's first law of motion, students. According to Newton's first law of motion, an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Students, this is a statement of Newton's law of motion. I'll explain you the meaning of the statement. According to this statement, according to the law of motion, first law of motion of Newton, if any object is moving, it will keep on moving only. If the object is stationary, the object will remain stationary, it will not move unless and until an a force is applied on that object. Suppose a object is in motion, then the object will continue in a motion unless and until any force is not applied, students. In the same way, if an object is in stationary state, is not moving, then it will remain stationary only unless and until any external force is applied on these objects. For example, students, for example, suppose I am having a football. Suppose I am having a football. I'll keep it on a football ground. Suppose football ground is not proper. There are many stones, small stones lying on that football ground. I'll keep that football down in that ground and I'll kick it. When I'll kick it, it will move, it will travel some distance and it will stop, students. It will stop. As the surface is not smooth, stones are lying, it will not travel too much far distance, it will stop a little near only. But suppose I'll do the same procedure in a ground having the smooth surface, that means only soil is there, no stone is there. So here in that case, students, in that case, when I'll kick the ball will travel little far, students. The ball will travel little far because now here in second time the stones are not lying on the surface, students, and the ball will able to travel little far distance. Suppose instead of doing this procedure in ground, suppose I am having a big hall, and in that hall tiles is there. I'll keep that ball on floor and I'll kick it. When I'll kick it, I'll see that it will travel a little more distance. It will go little far away as compared to previous first two times, students. Why? Because this time it is too smooth. Tiles is there, students. Tiles is there. It is too smooth. So there will be less friction, students. Less friction force of the earth. The friction force of the earth will be less and it will travel more distance. Suppose I'll do one more thing. I'll spread the oil on that floor in a hall, and now I'll kick the ball. what will happen, students? It will go maximum distance, students. It will go maximum distance. So what is happening here? We are continuously reducing the friction force. Here friction force is the one because of which the ball stops. Now as we are reducing the friction force, the ball travels more. Now if it is possible to reduce and make it zero, if it is possible to make the friction force, in practical it is not possible, students, but suppose if it is possible, we can say that the ball will not stop, only the ball will continuously move if friction force is not there, students. So here this is the exactly law of the Newton. According to Newton's law, if the ball is moving, it will keep on moving, it will not stop unless and until a friction force, that is here external force, is acting on that object, students. So here this is your first law of motion, students. Let us continue with the second law of motion. When we will continue with the second law of motion, students, the rate of change of momentum is proportional to applied force, and the change of momentum occurs in the direction of force. Students, to understand this statement, to understand this law, we need to understand momentum first. We need to understand momentum first. So here I'll tell you what is momentum. Momentum is denoted by P, students. Momentum is denoted by P, and momentum is the product of mass and velocity. Mass and velocity. Momentum P is equal to mass m into velocity v, students, into velocity v. So here momentum is nothing but mass into velocity, mass into velocity, students. So you will remember momentum is the product of mass and velocity. Mass and velocity. Momentum is denoted by P, and momentum is equal to mv. Now as per the second law of motion, the rate of change of momentum, rate of change of momentum, see here, mass into velocity. Suppose initial velocity, I'll explain you here, students. Uh, just a second, students. Here I'll explain you, explanation is over here, students. As per the second law of motion, the rate of change of momentum, students, suppose initial velocity is u and final velocity is v. Suppose we are having initial velocity u and final velocity v, then the momentum will be like, initial momentum will be mass into initial velocity, and final momentum will be mass into final. See, students, we have already studied momentum. When we are talking about momentum, students, I will come back to the law of motion, or second law of motion, but before we'll continue with the law of motion, I'll just explain you what is momentum. So we are learning momentum at present, and we have seen that momentum is nothing but product of mass and velocity. Mass and velocity. So momentum is mass into velocity, then initial momentum will be mass into initial velocity, and final momentum will be mass into final velocity. So here when we are talking about rate of change of momentum, when you will see the law, students, rate of change of momentum is proportional. So rate of change of momentum, what is rate of change? You know momentum now. What is rate of change of momentum? I'll tell you, students. Here rate of change of momentum is nothing but change in momentum per unit time. Rate of change of momentum is nothing but change in momentum per unit time. So here change in momentum is nothing but final momentum minus initial momentum. So instead of change in momentum, I am writing final momentum minus initial momentum, and remaining everything is same, students. Time is denoted by t. Let us continue here, students. Now here mv minus mu, m I'll take common, students. I'll take m common. When I'll take m common, I'll get v minus u upon t. I'll get v minus u upon t. Here v minus u is nothing but change in velocity upon t. Change in velocity per unit time is nothing but called as acceleration, students. We have already studied in our previous video. When you will see first video of this chapter, you will come to know. Here we are having v minus u upon t, that is change in velocity, is nothing but acceleration. So we'll get a here, students. We'll get a instead of v minus u upon t. So here finally we got rate of change of momentum is nothing but ma. Rate of change of momentum is nothing but ma. Now Newton's according to Newton's second law, the rate of change of momentum, that is nothing but ma is proportional to applied force. F is proportional to F, students. This is the second law of motion. This is the second law of motion. According to Newton, the applied force is directly proportional to rate of change of momentum. That means mass into acceleration, students. Mass into acceleration. This is your second law of motion. See, according to Newton's second law of motion, the rate of change of momentum is proportional to applied force. That means ma, rate of change of momentum, ma is proportional to F, students. When we are talking about F, students, F is equal to, when we will remove this proportionality constant, here we are having ma is proportional to F, students. So here what I will do, I can write in inverse way, F is proportional to ma. Now to remove this proportionality sign, I'll introduce a proportionality constant, and I can write F is equal to K M A, where K is the proportionality constant, students. So here K is chosen in such a way that K value is 1, students. K is taken 1, students, and our formula becomes F is equal to ma. Our formula becomes F is equal to ma. So you'll remember this formula, students. F is equal to ma. This is the formula which is derived from the second law of motion, students. Second law of motion. So we are having second law of motion. The rate of change of momentum is proportional to applied force, and the change in momentum occurs in the direction of force, students. In the direction of force. So you will remember this. Let us move ahead, students. We have seen this, how to derive F is equal to ma. Students, remember this F is equal to ma formula, like force is equal to ma. Students, this question will be repeated again and again. This formula will come again and again in front of you. If you'll remember, it will be good for you. Otherwise you will be in trouble when you will continue with your 10th standard, students. Let us continue here. Now Newton's third law of motion. According to Newton's third law of motion, every action force has an equal and opposite reaction force which acts simultaneously. Students, here action and reaction terms that express force, students. Here when we are talking about action and reaction, these two words, they express force, students. Action and reaction. So whenever we are saying action or reaction, it is force, students. When we are applying force, for every action force there is equal and opposite reaction force, simultaneously, students. This is the third law of Newton. Here these forces act in pairs, students. Whenever there is action force, then only there is reaction force. If action force is not there, the reaction force will not be there, students. So if you want, these two forces will be there in pairs, students. These two forces will be in pairs, students. Action and reaction forces act simultaneously. They work at the same time, students. At the same time, action and reaction forces act on different objects, students. If action force is acting on first object, the reaction force will act on second object. For example, I will push the wall. I'll be pushed by wall, students. I'll be pushed by wall. I am repeating the sentence. If I'll push the wall, I'll be pushed by wall. So here, if I'll apply the force on wall, the force will be applied on me by the wall, students. This is the reaction force. So here you will remember, students, the action and reaction forces, they act on different objects, students. While there are few examples. While hitting a ball with a bat, the speed of the bat decreases, students. Initially, while playing cricket, when we hit the ball with the bat, what happens, students? Ball goes far away, but the speed of bat reduces and bat stops. At the same time, when we miss the ball, what happens, students? Sometimes bat is going away, or we feel turn we will have to do a lot of hard work to control that bat in the case when we miss the ball while playing the cricket, students. In the same way, when you will fire the bullet in a gun, when you will fire the bullet with the gun, what happens, students? The gun recoils, moves backward when a bullet is fired, students. When a bullet is fired, this is the example of reaction force, students. And last one, mechanism of firing of rocket, students. Firing of rocket, when rocket is fired in upward direction, the engine which is there at the base, at the bottom of the rocket, releases a lot of gas with the huge pressure in downward direction, in opposite direction. And because of that, this force reaction force is generated, the reaction force is generated, and the rocket moves in opposite direction, in forward direction, students. So when the gas is released by the engine at the base of the rocket in the backward direction, the rocket moves in the forward direction. This is again based on the third law of Newton, students. This is again based on the third law of students. So students, for today I'll stop my lecture here only, and in the next video we'll continue with the lecture, and we'll learn the conservation of momentum, students. Conservation of momentum, and we'll solve few sums based on the chapter, based on the formulas in this chapter, and we'll stop today's lecture. Thank you for attending today's lecture, students. We'll meet in next lecture. If possible, students, don't forget to subscribe the channel, so that you will not have to search the video. You will get the video whenever it is uploaded directly, students. Thank you very much, students.